All right, so today we're going to do the last thing that's in chapter 16. Apparently I forgot to include it in the PowerPoints. Sorry, complex ion equilibria. So we've only been like 2 PowerPoints. Your last mastering for the test is tonight. There's an individual quiz today, review day on Friday, and then your test is on Monday. Awesome. So, let's talk about complex ions. So a simple ion is something that consists of one or only a few atoms. So like sodium chloride or chlorine, something like that. Those are all considered simple ions, which is everything that we've dealt with up to this point. So a complex ion consists of a metal ion, covalently bound to 2 or more anions. Why would a metal choose to stick to an anion? We'll back up. An anion has what charge? Negative charge. Transition metals are typically positively charged, right? If you're thinking across the middle, we usually deal with positively charged metals. So we're going to stick them to negatively charged anionic groups. So these would be things like chromium, hexammonium, or let's see what else. Right, aluminum, tetra. What was the one you guys did in lab? You had something, it was like Fe. Yeah, it was potassium, ion oxalate, hexoxalate, tris oxalate, whatever that was, right? That is a complex ion, right? You have the iron in the center, and you have the oxalate groups stuck to it. So that's considered a complex ion also. That's obviously not the right formula. Whatever was in lab, that one. When you're reading your notes, go back and say, the one we did in lab. Yeah, that one in lab. All right, so when we talk about complex ions, we can also look at their solubility. All right, complex ions have one more K for us to talk about, because you didn't have enough Ks before. One more. It's K little f, which is the formation constant. So the formation constant measures the process of making the complex ion. So it's done the exact same way, products over reactants, but it would be for the making of the complex ion. So let's say I had this chromium molecule up here. So in words, let's say I am starting off with the hydrated form of this chromium, and I want to form the ammonia version of it. So that's what's becoming, this is what's starting with. So we know for sure those are our starting and final products, right? We started with this. I want to make it that. It says in the presence of ammonia. Is this balanced? No, it is not. What do I need to do to balance it? Okay, 4 of those, and what else? 4 waters. All right, so now I got my balanced chemical equation. I'm now going to figure out the formation constant of this. What would go in the numerator of my formation constant? Do I include the water? Right, no, I just include this. Okay, then I have this on the bottom for sure. What's the last thing I have to put in there to make it finished? Yep, we gotta raise that to the 4th. Good there? Like it's a warm up, it's just kind of just what we've done, now it's just with much bigger molecules. All right, let's do an example. And this will pull together some of what we've done before, way back in chapter 14, with what we did in chapter 16. It's kind of a cumulative problem. Alright, so in black and white photography, excess silver bromide is removed. Using 1.0 molar with a solution. thiosulfate. It is. It's a little too. That should be 3 minus. Sorry, 3 minus. Okay, so just like we did before, oh, sorry. I was reading and writing at the same time. So we're going to find the solubility of silver bromide in water and the solubility of silver bromide in the 0.1 molar thiosulfate solution. So the same problems we had before, right? On, I guess, last Friday, where we looked. We'll do, I guess, I'll try and be consistent. I'll make it 1.0. 1.0 molar. So there's another common ion problem, right? We had the same issue before where we had a similar ion that will change the solubility, right? So let's find the solubility of this silver bromide in water. All right, so we start off with silver bromide as a solid. What 2 ions does it make? Yep. So what would be the KSP equation for just this? Yep. Good so far? All right, and then we'd go to the back of the book and we'd look up the KSP, and we would find that to be 5.0 times 10 to the 13th. So what are the solubility, what are the concentrations of each of these? Yep, take square root. You should get something like something in that ballpark.
That's in the layer?
It is. Yep, it's a. Yep. Good there. That was just review, just a warm up. All right. So let's do now. We have a common ion. All right, so first thing we have to do is we have to write our new balanced chemical equation, right? Because the one we just had, wherever that went. Oh. All right, so this equation doesn't have the thiosulfate in it, right? So we have to come up with a new balanced equation that will relate this with what we're adding. So this is what we had before. Right, so that's the equation we had before. Just silver bromide dissolving. We want to find the equation that relates the thing we know we're going to make is that equation balanced? No, what do I need to do to balance it? Okay, I need two of those. So now what is my net ionic equation? What cancels out in this equation? So I can find the net ionic. There's one thing that cancels out. Okay. Right, the silver ion appears on both sides. That cancels out. Kind of like what you did in lab, depending on what week you had lab, the net ionic equation. So now my new reaction do we have an equilibrium constant for this new equation? We don't. We have, what kind of equilibrium constant did we use 5 minutes ago? K, lowercase what? This was KSP, right? This was the solubility constant. This will be the KF, right? Because I'm forming the thing I need. If this is KSP and this is KF, how do I find the K of this new reaction? You don't add them, you multiply them. I've added two equations, so I multiply the K's, which is what we did way back in chapter 14 when we had individual little K's and we rotated around the equation to find. So we're going to do the same thing. So KSP we already had, that was what, 5 times 10 to the negative 13th. Formation constant would look up in the back of the book. That's times 10 to the positive 13th. Using two sig figs, we get 24. So now we are ready to use this to find the concentration of those silver ions. So if you could possibly do this without an ice chart. I like it with an ice chart. What was the molarity of the thiosulfate we put in there? It was 1, eventually, when I got it right. 1 molar. There wasn't any of that. Right, I subtract from this side. How many X's do I subtract from the thiosulfate? 2. I add 1 over here. I add 1 over here. I'll call this K overall. I don't have a good snazzy name for it. K, S, F, P, S, P, F. Something like that. K overall. What would be on the numerator? X squared. Then what's on the denominator? Right, this guy. This would not be a good case to assume that X is small because we're only starting off with 1 molar and our K is 24, which is pretty big. So what can I do to simplify this equation without doing the simplification step? Oh, I know, I forgot. Squared that. That's why. Right, we're going to do square root. Right, if I had written out the K overall for this, which I probably should have, that's why you need an ice chart, I would have this. Right, because I had 2 of them, so I have to square it. So really, I'm squaring the bottom and squaring the top. So now what's a good simplification step? Yep, square roots. Square roots for everybody. All right, so now I have X over, what's the square root of 24? Like 4.9. All right, what do I do at this point? What units will that be in? Okay. And what is the the concentration of? Yep. How do I feel about that? It's just the same stuff we've done with just bigger molecules. Kind of putting it all together. Yeah, Sarah. Where am I looking? Oh, yep. 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 Yep.
So assume X is small in every other case except for these.
Yes. This one would not be a good case to assume it because the K was so large. Right, because usually our Ks are like to the order of minus 10 or something. We have a K of 24, it indicates that you're going to make a lot of products, so that X will not be small. How do you feel about that? Good? Any other questions?
How did we get to K? That's
So like in the example I did at the beginning, I had this chromium thing becomes that in the presence of this. Here I had silver. I knew I was adding thiosulfate to it. So one of the products had to be thiosulfate. And there wasn't any water or anything else, so it's just combining them together. So it's just the formation of whatever crazy ion the problem asked for. Yep, it's in the same appendix as KSPs and KAs and every other type of K we've talked about. The K appendix. Any other questions? Well, then why don't we do the quiz? Does everyone have a calculator? If not, you'll need to fish one out. Get a calculator out.